recording.
All right, so I'm Casey Armstrong, and I'm here with Carlos Perez to talk about his newest book. So, can you tell us what it's called?
Hey, yeah, the book is a pattern language for large reasoning with a subtitle Long Horizon Thinking Using ChatGPT o1 Pro.
All right, and what motivated you to write this book?
When OpenAI released their o1 model, right, and started providing a higher price tier ChatGPT Pro level at $200 a month, decided to try it out. And as I was working with it, I sort of realized that it was very different from the previous kind of prompting that I used to do with ChatGPT 4. Previously, I also wrote a book on prompting patterns for GPT-4. That was 2 years ago. And, it was very informative on how you would actually structure your prompts. But what I noticed was with o1 Pro, it had a very different feel. I was curious in investigating, are the patterns actually different for this kind of new model? Interesting enough, it turns out there are differences. It's important to know the differences so that you can actually leverage the power of these new kinds of large reasoning models.
And with that said, can you explain what are large reasoning models like OpenAI's O1, and what are the key differences in prompting between large language models and large reasoning models?
Yeah. So large reasoning models, as opposed to large language models like GPT-4, are large language models that actually have been tuned to actually reason in long sequences. When you actually use it, you actually see this. So unlike a LLM, large language model, that would respond very quickly, a large reasoning model will actually take time. It might take a minute, it might take several minutes, depending on the how much reasoning it's doing, it's performing. Underneath the covers is actually running several iterations or several request response pairs of a large language model that has actually been tuned through reinforcement learning to actually know how to actually chain its reasoning together. So it's very good at figuring out what are the things that it needs to reason about and actually stitching that together. If it hits any kind of roadblock, it knows how to backtrack and take another path. That's why it sometimes takes different times to reason about the requests, meaning for more difficult ones, it actually takes more time because it's for a bigger space.
Okay. All right, so what are the key themes of this new book?
Oh, I forgot the second part of your question. Let me
Oh,
address your second part of your question. How is the prompting different in large reasoning models as compared to LLMs? And the,
yeah.
the main difference is that the large reasoning models actually have a much more narrow scope of their thinking. So they're very good at crafting details, but they aren't as good as broadly bringing in information. Unlike LLMs, where you can upload a document and actually query a document, the current o1 models don't have that option. What that kind of means is that all the information that you need to actually reason about something must be available in the context. So you actually have to manually kind of like bring it all in. So you have to say a lot more to set it up.
Mhm.
Rather than an LLM, you can say a little bit, and because they're kind of in tune to chat, you can incrementally build up the complexity. With M's or reasoning models, it's helpful to have everything up front and then execute. So the pattern language that I have is different from the LLM pattern language in that there's an assumption that you combine patterns together rather than just have them individually. In the previous GPT model, you would have patterns, but the assumption there was that you would use them incrementally, one after the other. With LRMs, you would use them in combination in the same context and then apply them together rather than incrementally. So that's the big difference.
Okay, so it sounds like the new reasoning models are for very specific types of reasoning tasks.
Yeah, well, I would say they're a different kind of reasoning task. Not
Okay.
exactly the same. It's very subtle. If you're gathering information, say you want a broad query about things, then a GPT-4 would be better suited. If you're trying to query about a domain that you're not familiar with, then a GPT-4 might be better. But if you know what you already know what you're looking for and what you know what to bring in, and you need to actually analyze that information, then the reasoning model would be more ideal. So if you already know all the important things and you brought them in all in within the context, then a O1 model would be ideal for that. So there's a slight difference in use case.
All right, sounds like we need a book about this. So, what are the key themes of the book?
The themes of this book is that we give you a new way of thinking about how you would actually prompt O1 models so that you maximize the reasoning of that model. And also we want to maximize the iterative and collaborative process. So not only are we just doing single queries, we want to show how you iteratively and collaboratively work with these kind of models. And the goal is so that you would be able to maximize the use of these kind of models as opposed to
Okay. And I'm a little surprised to find a couple inspirational characters in this book. Can you tell me about what inspired you to integrate Christopher Alexander's and Charles Sanders Peirce's triadic thinking?
in the previous book that I wrote, A Pattern Language for Generative AI, I saw the opportunity of using this notion of pattern languages. Christopher Alexander, who is an architect, about in the late 70s, he proposed a way to capture the tacit design knowledge of architecture using what he called pattern languages. He recognized that there were these kind of design decisions that were being made that would benefit if it was captured in a language, be reused by other practitioners or other architects. That idea was picked up later in a lot of other fields like user interface design and software development, where new design languages were created for that particular domain. So what I saw was missing in with GPT was that there wasn't a pattern language that was articulated so that you could actually create better prompts. So that's why I brought in the idea of Christopher Alexander's pattern language. Now, in my own investigations with regards to deep learning and large language models, I realized that Charles Sanders Peirce's ideas on semiotics was very relevant to the domain. I'm bringing his concepts and merging it with Alexander's patterns to create a new kind of pattern that incorporates both ideas. So you'll see in the book that the patterns here are slightly different from other patterns that you've seen before, in that it includes Peirce's triadic thinking. So I found that useful in this book, and that's one of the unique things about this pattern language, in that it leverages the ideas, the triadic thinking of Peirce, as well as, and you'll see how it's actually used not only in just describing every pattern, but how you would actually compose patterns together. The idea here is that we have these patterns, they're meant to be included in parallel within the same context, but that brings up the question, how do you actually correctly compose them together within the same context? And that's where Peirce's triadic thinking is actually helpful, and you'll actually see that in the book.
Okay, so yeah, it sounds like this pattern language and triadic thinking is this unique and foundational methodology to these pattern language books.
Well, I've not yet applied Peirce's semiotics on the previous version of the pattern book, but I found it to be very useful in this context for larger reasoning models.
Okay. So the O1 model appears to emphasize a balance between structure and spontaneity. Can you describe this balance for us?
Yeah, so in the book, I have this notion prompting versus prompting, right? And the idea here is that in the first kind of prompting, that's is the kind of prompting where you detail everything. You would expect a large reasoning model would be very good at that. So you detail every constraint. You specify everything in precise detail, right? But there is an alternative approach, and this one would foster greater creativity and exploration, is that you're a little bit more with your terminology, your prompting. And the idea is that you really want to have the large reasoning model fill in the gaps for you. So in LLMs, it was useful to spell out the chain of thought. So these are the steps that you're going to go through, or even tell the LLM to think step by step. So those were useful prompts. Those are not as useful in a large reasoning model because in a large reasoning model, it does that for you automatically. So you don't want to specify that because if you specify it, you would actually restrict thinking of the large reasoning model. So a lot of cases you would take out the chain of thought thinking. And in the same analogy, you would also take out a lot of constraints that you would normally have introduced. And by removing those constraints, you get responses that have greater surprise, greater creativity. This is a kind of fundamental pattern that you can choose either one and just play around it depending on your goals.
Yeah, it's so interesting to document all these different transition points. But given this super rapid evolution of large language models, how do you foresee the ideas in this book influencing next generation AI systems?
Yes, if you look at the OpenAI roadmap, the level 3 is this notion of agentic AI, and level 4 is this notion of these AI that's innovative. I guess the consensus is that we're in level 3. 2025 is, I guess, the year for agentic AI, and that's the notion of a collective set of intelligent AIs building more complex outputs or products. So these kind of things happen in multiple iterations to actually build something. So rather than in the old days, it would just like a kind of one shot request response, and maybe you might stitch them together, but not stitch them together in more complex ways. So the notion of agentic AI is that it runs in the background and does all this stuff for you, like write an entire program for you or write an entire paper for you and so forth, right? The pattern language give some prescriptions to how you would actually prompt these systems so that they can achieve this kind of collective intelligence. The other stage that we haven't reached yet, but something in the future is this notion of innovative AI. This kind of thing, this notion of AI that kind of thinks out of the box, right? And the problem there is these large language models will have difficulty thinking out of the box because they're kind of confined with the language they already know. So to be able to think out of the box, you have to be able to self-author new words, new concepts, reframe previous or existing mental models, right? Pattern languages are very useful in that regard because if you go back to the original motivation of pattern languages, it was this idea of being able to capture tacit methods, tacit techniques, and making them explicit so that you could use them in your design and explain your designs. Pattern languages create new languages. They create new words, right? So for a particular domain, you're actually creating new concepts, new words based on your experience in practice. And that's where I see how there's potential to inform these kind of AIs that would think out of the box, because now you got some sort of method that shows how you can actually create new words, a new language to express something. Right. So what I see in the future would be these AIs would invent their own mental models. You can explain it through that mental models, and or they can explain it through your mental models mapping to their mental models. So there's this kind of evolution in language that is necessary to think outside of the box.
So this is my last question for you. So are there any updates or iterations that you anticipate adding to this particular framework as models continue to evolve?
Yeah, I think this is a very promising framework that can be extended into these two areas, this notion of agentic AI and this notion of innovative AI or AI with ingenuity, right? And I think the approach looks extremely promising, and the tooling is getting much better. So a lot of this book actually was created with the help of O1 itself, right? So O1 actually proposed a lot of the parts of the book, but I was using the same and informed the method for me to gather more information and improve the ideas of the book. So there's this kind of self-referential feeding back of ideas and using the tooling to discover more ideas and using those new ideas to refine the present ideas and so forth there. So there's this feedback, this iterative loop, this flywheel that leads to greater improvement of the current, as well as it gives a opening into these new areas like agentic AI and innovative AI.
Fantastic. So where can people find your books and other information?
Look at my profile in Twitter. You'll find the government link, and it'll have all my books, so you can find it there. Another point, though, is the book also comes with a GPT, the entire book loaded into it, so you can actually query it. The fascinating thing is that you can actually use this GPT to analyze your prompt, and it will tell you exactly which patterns that you used in your prompt. So you can reverse engineer other people's prompts, right? And then learn from that and then extend that further using the GPT. So it's fascinating that the book itself, all right, is actually something that is an active kind of thing. All right. A lot of that we can expand further because once you have this notion of patterns, you can use the patterns themselves to explain ideas. So, for example, it would seem that it would be difficult to explain how a prompt is constructed without a common language. You would just use common words and it would be a little bit confusing and ambiguous. But by having a pattern language, you can explain it using the pattern language, and then the user can refer to each pattern to get more detail onto it. So you can have this kind of explanation that is much richer than what LLMs would in general generate. So this is actually a good opportunity also to build AIs that are better at explaining things. All right. So you can imagine yourself in a domain.
Agriculture.
So in agriculture, there are a whole bunch of terminologies and different ways of doing agriculture. And you might have the traditional agriculture, and they have their own terminologies, and you might have regenerative agriculture with their own terminologies. So what you do is, say you go into this new field, regenerative agriculture, it's going to have its own language. Then you make explicit through pattern languages the language that is spoken in regenerative agricultural circles. So it becomes a pattern language. Once you have this pattern language, then you can use this pattern language to explain all the different methods that you're doing within regenerative agriculture, right? Using a different language from the more traditional agricultural language. Now, though, of course, there's a question, can you actually have the AI bridge that gap? Possibly too. That's another thing, right? So that means you would explain regenerative agriculture from the perspective of traditional agriculture and back and forth, right? So this notion that you have these kind of different languages for different domains and having AIs leverage that to improve their explanation or actually bridge explanations, then that has a lot of potential.
Well, that's fantastic. What an exciting time to be alive. So many developments all the time. So thanks for chatting. Thanks for chatting with me today. I
Okay,
appreciate
thanks
it.
for having me. Thanks.